Let us consider the second problem on Sturm-Liouville problem. We have to solve this Sturm-Liouville problem by finding the eigenfunction and eigenvalue corresponding to the Sturm-Liouville system. So for us to solve this, what are we going to do? To solve this problem, we are going to find the eigenvalue by considering three cases. Our first case is when lambda is equal to 0. Second case is when lambda is less than 0. While third case is what? When lambda is greater than 0. So in this case, what do we have here? We have the solution to this. We have 4 exponential minus s y point. We have y plus 1 plus lambda, then exponential minus xy is equal to 0. You can see this. I explained in our previous lesson when I said if you are given p of x, y point, and point, that how are we going to solve this? When I said that we are going to differentiate p of x, y point, plus we are going to differentiate this one. If we take this one, differentiate this one again, second order. Then we take the differentiate with respect to x. I'm going to have x times 1. I'm going to have p of x, y point. So we're going to use this in form of this. You can see that this one satisfies the Sturm-Liouville problem. So it means I'm going to differentiate this. We have 4 exponential minus sy point. Then if I differentiate the y over dx, I'm going to have what? D square y over dx square, that is y double point. 4 exponential minus sy point. I have this already. Then I have another point. If I differentiate another point again, respect to what? Respect to what? The y over dx. This statement means y dy over dx, and I have 1 again. So what am I going to have? D square y over dx square, or y double point. So I'm going to have y double point plus, I'm going to now differentiate this one, exponential s with respect to x. If I differentiate exponential minus s, I'm going to have what? Minus exponential minus x, minus 1 exponential minus x. So minus 1 times exponential minus x, I'm going to have. If I differentiate respect to x here, I'm going to have 1. But minus is here, minus 1 times 1. Minus times 1 is minus 1. So minus 1 multiplied by everything here, I'm going to have minus 4 exponential minus x y point. So I'm going to have minus 4 exponential minus x y point. You can see that this one satisfies this, where I have plus q of s plus lambda r of s w y is equal to 0. It's something like this. You can see that it's satisfied. So what am I going to do next? Is what? So let me open this bracket plus, if I use this one to open 1 times this, I'm going to have exponential minus xy plus lambda exponential minus xy is equal to 0. So I've considered this. So let's assume, I've explained in our previous lesson that we assume that our y is what? Exponential ms. If I differentiate this with respect to s, I'm going to have, if I differentiate x here, I'm going to have 1. 1 times m will multiply this, I'm going to have m exponential ms. If I have y double prime, I'm going to have m squared exponential ms. So whenever I see y double prime, I'm going to plug in this. So I'm going to have 4 exponential minus x. Then we have exponential minus s already. I can divide both sides by exponential minus s. So if I divide both sides by exponential minus s, what am I going to have? If I divide both sides by exponential minus s, exponential minus s is going to cancel. I'm going to have 4y double prime minus 4 exponential minus s divided by exponential minus s. I'm going to have only 4y prime, then plus exponential minus x divided by, I'm going to have plus y plus lambda is equal to 0. You can see. So what am I going to have? So this is the general formula for this. So we now consider what? You consider case 1. Case 1 is what? When lambda is equal to what? 0. So it means whenever I see lambda, I'm going to put what? I'm going to put 0. So what am I going to have? I'm going to have 4y point minus 4y point plus y plus 0 is equal to what? 0. So I'm going to have 4y point. So what's our y point? Y point is exponential ms. Exponential ms minus 4y point m exponential ms plus y. My y is what? Exponential ms. My y double prime is m square. Not exponential. My y double prime is m square exponential ms. So you can see for this is equal to 0. So when lambda is 0. So what am I going to do? Divide both sides by what? Exponential ms. Exponential ms. And here exponential ms. Why this one is exponential ms? So here will cancel, exponential ms will cancel, exponential ms will cancel, here will be 1. So I'm going to have 4m squared. 4m squared minus 4m plus 1 is equal to 0. So you can see that this is an auxiliary equation. The reason why we are doing this is what? When solving Sturm-Liouville problem, finding the eigenvalue. Finding the eigenvalue and eigenfunction for this. We are going to consider, we are going to solve it. We are solving homogeneous differential equation. That is, this is a homogeneous differential equation because g of s is equal to 0. When g of s is equal to 0, the equation is homogeneous. So we are going to solve it as homogeneous. And we are going to consider our case, 3 cases. Case 1, we are doing case 1 when lambda is equal to what? 0. So what are we going to do this? You can see that this is an auxiliary equation. This is an auxiliary equation. Auxiliary equation. So how are we going to solve this? So we are going to solve this. It means 4m squared minus 4m plus 1. To solve this equation, we are going to what? We are going to, I can use factorization method to solve this. I can use quadratic equation to solve this. So because of our time, so using factorization method, I'm going to have 2m minus 1, then 2m minus 1 is equal to 0. That is our, if you look for a 2 number that's going to give us 4, the negative term is what? 2 and 2. So what am I going to have next is what? To have next is what? To take 2m minus 1 to equate it to 0. 2m minus 1 is equal to 0, or 2m minus 1 is equal to 0. So my 2m is equal to what? 1, or 2m is equal to what? 1. So I'm going to have, so my m is what? 1 over 2, or my m is also what? 1 over 2. You can see that first m is the same as what? Second m. This is a repeated root. Repeated root. And when you have our repeated root, our general equation is, general solution is y of s is equal to what? A exponential ms plus bs exponential ms. So I'm going to, whenever I see m, I put 1 over 2. I'm going to have a exponential 1 over 2s plus b s exponential 1 over 2x y of x. To find the boundary condition, I'll be given the boundary condition. Y of 0 is equal to 0, y of 1 is equal to 0. So at y of 0 is equal to 0, it means our 0 here is x is equal to 0. So I'm going to have y of 0, that is y of s is what? 0. So I'm going to have a exponential 1 over 2 s is 0 plus b s exponential 1 over 2 s is 0. So here is going to cancel. I'm going to have a n to the power 0. 1 over 2 times 0 is 0. N to the power 0 is what? N to the power 0 is what? 1. A plus bs. So I'm going to have, so y of 0 is what? Y of 0 is 0. So a is equal to a plus bs. So my a is what? Minus bs. Because if I take this one to here, I'm going to have a minus bs. I can include this one in equation 1. So my equation 2 is what? How am I going to? So my second one is to what? To find y of 1. Y of 1 is equal to what? 0. What am I going to do? Y of 1 is equal to 0. So remember that my s is already 0. So I don't need to write x here again. So here will be what? 0. Here will be what? 0. So my a is equal to what? A is equal to what? 0. So my y of 1 is what? 0. So it means my s is, that is my s is equal to 1, y is what? Y of 1 is equal to what? 0. That is s is equal to 1. Whatever I see, so y of x is equal to what? A exponential ms, a exponential 1 over 2x plus bs exponential 1 over 2x. So it means my s is 1. Y of 1 is equal to a exponential 1 over 2, 1 plus b is exponential 1 over 2, 1. But my y of 1 is what? 0. I'm going to have 0. Then a exponential 1 over 2 plus b is exponential 1 over 2. 1 over 2 1 times 1, I'm going to have this. Remember that my a is equal to 0 already. So here will be what? 0 plus b is exponential 1 over 2. But divide both sides by exponential 1 over 2, I'm going to have 0 is equal to what? Bs. Divide both sides by what? S. So therefore my b will be what? 0. You can see that my a is equal to b is equal to 0. We have a trivial solution. Trivial solution. A trivial solution is a solution where our constant, our general solution constant, a and b are the same, which is if it is the same, if it is 0, if both are 0, a is equal to b is equal to 0 is a trivial solution. So my second equation is to what? My second case is what? My second step is to what? To case 2, to consider case 2 where lambda is less than what? 0. That is, if lambda is less than 0, it means lambda is what? Negative. It means I'll go to my Sturm-Liouville problem that I was giving. Whenever I see lambda, I put what? Negative. So what am I going to have? I'm going to have 4 exponential minus s y double prime minus 4 exponential minus x minus sy prime prime. Then what do I have here? I have 1 plus. So it means I'm going to have this 1 plus lambda. So it means when lambda is negative, I'm going to have 1 minus lambda. So I'm going to have 1 minus lambda, 1 minus lambda, then multiply by what? Exponential what? So this space cannot contain it. So I'm going to consider this. Whenever I see lambda, I put minus lambda. So I'm going to get my answer back. So therefore, I'm going to get this one back and this one back. Here will be what? 1 minus lambda. Then use this one to open this one. I'm going to have this one back. Here will be what? Minus lambda exponential minus xy. So I'm going to have 4 exponential minus s y double prime, then minus 4 exponential minus x y prime prime, and then followed by what? Plus 1 minus lambda. If I use 1 to multiply exponential minus xy, I'm going to have plus exponential minus xy, then followed by what? Minus exponential minus what? Minus lambda exponential. I'm going to be writing this. This is 4yy. So let us consider this 4 exponential minus sy double prime minus 4 exponential minus sy prime plus exponential is common. So I can just say exponential minus sy, then 1 minus lambda y is equal to 0. It's still the same thing. If I use this to multiply this, I'm going to have this. Minus, if I use this one to multiply this, I'm going to have this equal to 0. So what I'm going to do, divide both sides by what? Exponential minus xy. I'm going to have exponential minus x. Divide both sides by exponential minus x. Exponential minus x. Here you cancel, here you cancel, here you cancel as well. I'm going to have 4y prime prime minus 4y prime, then plus, what do you have here? 1 minus lambda y is equal to 0. So remember that our y double prime is m squared. When we assume 4m squared minus 4m plus 1 minus lambda y is equal to 0. We can use it. We don't know what lambda is. We want to get the value for lambda. So how am I going to solve this auxiliary equation? I cannot use factorization method here. Why? Because I don't know the value of what? My lambda. So best way is what? I use quadratic equation, whereby I'm going to say my a is first m, then my b is what? Minus 4, and c is what? C is 1 minus lambda. 1 minus lambda. Remember that if I have y here, I'm not going to have y again. The reason why is that y is outside already. So y, if y will be taken as 1, y will be taken as what? As 1. So I'm going to have, so y will be omit, I'm going to have is equal to 0. Y will be omit is equal to 0 because if this one is able to cut this, sorry, this is where I made mistake. If you use this one to multiply this, you're going to have this minus. This one times one, you're going to have this one. Expression. So here will be y. So if I now take y is what? 1. So I'm going to have 1 here. So I hope it's correct because my y double prime is m squared exponential ms divided by this. My y prime is what? Exponential ms divided by exponential ms. I'm going to have 1. So that's why I have 1. To solve this auxiliary equation by quadratic method, so I'm going to have m is equal to minus b plus minus square root of b squared minus 4ac all over 2a. So I'm going to have m is equal to what? Minus 4 plus or minus b squared whole by b squared minus 4 raised to the power of 2 minus 4 times c 1 minus lambda. Then over what? 1 over what? 2 times a, which is 4. So I'm going to have m is equal to minus times minus is what? 4. Minus times minus is what? Plus. This is 4. Plus or minus square root of b squared. That is 4 is minus 4 is the power of 2 is 16. Minus 16 multiplied by what? 1 minus lambda. All over what? All over 8. So I'm going to have m is equal to 4 plus or minus square root of 8. So 16 minus 16 minus 16 and minus 16 minus times minus plus what? 16 lambda. Then take the square root of this. So what am I going to do next is what? This is 16. 16 minus 16. I'm going to have m is equal to what? 4 plus or minus 16 minus 16 is what? 0. What do I have here? 16 lambda over 8. So what am I going to do next is what? 16 lambda. I can write 16 lambda as what? Square root of 16 then square root of what? Lambda. So what is square root of lambda? Square root of 16 is what? 4. So I'm going to have m is equal to what? 4 plus or minus 4. And then with lambda, I don't know what lambda is with lambda. Then over what? All over 8. So I can write this one is as 4 plus 4 with lambda over 8 over 8, or m is equal to what? 4 over 8 minus 4 with lambda all over 8. So 4 here 1, 4 here 2. So my answer will be to have m is equal to 1 over 2 plus with 4 here 1, 4 here 2 with lambda all over 2, or m is equal to 1 over 2 minus with lambda all over 2. 4 here 1, 4 in 8 2, 4 here 1, 4 here 8 is 2. Here is square root of what? Lambda, or with lambda. So you can see that over 2, we have over 2 over 2. So what are we going to do here? Since we have the same denominator is the same, I can say that m is equal to what? 1 plus root lambda all over 2, or m is equal to 1 minus root lambda all over 2. So you can see that my general solution y of s is now the a, they are now repeated with a exponential ms plus b exponential ms. This is my general solution. So whenever I see m, I put this. So I'm going to have y of s as what? A exponential 1 plus root lambda s plus b exponential 1 minus root lambda and x. So what do we have here? So this is the solution. But we have the boundary problem as y of 0 is equal to what? Y of 0 is equal to what? 0. So we are going to test this where y of 1 is equal to 0. So y of 0 means s is 0. That is s is equal to what? 0. So I'm going to have 0 here, then a exponential 1 plus root lambda, here is 0, plus b exponential 1 minus root lambda, also 0. So anything multiplied by 0 will be what? 0. So I'm going to have y of 0 is 0, a exponential 0 plus b exponential 0. So 0 is equal to what? A plus b. So therefore my a can be what? My a can be what? A plus b is equal to 0. A minus b. I can write this one as equation 1. So let me test for when y of 1 is equal to what? 0. At y of 1 is equal to 0. I'm going to have y of x y of 1 is equal to a exponential 1 root lambda x plus b exponential 1 minus root lambda x. So my x is 1. My x is 1. So I'm going to have the same thing because everything multiplied by 1 will give me the same. So my 1 of 1 is 0. A exponential 1 plus root lambda plus b exponential 1 minus root lambda. So my a is what? Minus b. So whenever I see I put minus b. So I'm going to minus b exponential 1 plus root lambda then plus b exponential 1 minus root lambda. You can see from here that if I find my a, 0, a will be 0, 0. We don't have is a trivial solution. That is, since we don't know what a is, we don't know b. So that is a is 0, b is 0. A is equal to 0 and b is equal to what? 0. So in this case, we have a is equal to b is equal to 0. It's a trivial solution. Our case 1 is always a trivial. Our case 1 is always trivial solution. Case 2 is always trivial solution. But case 3 will lead to trivial solution. But we are the one that will not let it to be a trivial solution by adding another value, by generating another way, whereby our case 3 will not be a trivial solution. So my next step is what? To solve case 3 when lambda is greater than 0. And if lambda is greater than 0, it means lambda is positive. So whenever I see lambda, I put what? Plus. So I'm going to have, in this case, I'm going to have 4y prime prime. So because of our time, minus 4y prime plus 1, then 1 plus lambda. You are saying when lambda is negative, I have 1 minus negative. So in this one, lambda is what? Positive. That is plus lambda is equal to 0. So I'm going to have 4y double prime minus 4y prime plus 1 plus lambda is equal to 0. So from here, my y square is 4m square minus 4y 4m plus 1 plus lambda then is equal to 0. We are going to use quadratic equation to solve this as well. So my a is 4, my b is minus 4, while my c is what? My c is 1 plus lambda. So I'm going to have m is equal to minus b plus minus b square minus 4ac then all over 2a. So my m minus b is minus 4 plus or minus square root of b square minus 4 to the power of 2 minus 4 times a, 4 times what? 1 plus lambda. Then all over what? 2 times a, which is what? 4. So I'm going to have m is equal to minus times minus is what? Plus. So I'm going to have 4 plus or minus. Lambda is 16 minus 16, then 1 plus lambda all over what? 8. So my m is what? 4 plus or minus 16 minus 16 plus 16 lambda. Minus times plus is minus. Minus 16 lambda. Square root of what? Divided by what? 8. So minus 16 lambda. So whenever we have a negative, this one is going to turn to what? A complex form, whereby we are going to have, I can write this one as 16 square root of 16, then what? Square root of lambda, then I. So we have minus. So minus will give me what? 16. That's minus 16. Whenever I have minus 16, I'm going to have 14i. That is, I'm going to have what? Imaginary value. So I'm going to have 14i with lambda. So my m is now so I'm going to have n is equal to 4 plus or minus, so square root of minus 16 lambda. Square root of minus 16 lambda, I'm going to have 4i lambda. 4i with lambda, because we don't know what with lambda is. All over what? 4. So in this case, I'm going to have n is equal to 4 plus 4i with lambda all over 4, or m is equal to what? 4 minus 4 lambda I all over 4 all over with lambda. So 4 and 4 here 1. So I'm going to have m is equal to 4. 4 is averting this, averting here 1 plus I with lambda, or m is equal to what? 1 minus I with lambda. So this is our solution, because if I have 4 over 4 here, sorry, it's not 4, I have 8. Here is 8. Is 8 is 8. So I'm going to have 1 over 2. I'm going to have over 2. So what I'm going to do next is to what? So my y of s, I see is a conjugate. It's a conjugate root. I'm going to have conjugate root means exponential alpha s into a cos beta s plus b sine beta s. So I'm going to have, so whenever my alpha is my real part, that is the number that is what value, that is not I, my real part 1 negative, number that is positive or negative, which is what 1 over 2, or fraction, rational and irrational number, that is my alpha is what real part. So while my beta is what imaginary part is what negative. So I'm going to take what the coefficient of what I, imaginary part, that imaginary unit is what the coefficient of imaginary unit is what with lambda over 2. So which is what I'm going to have with lambda all over 2. So I'm going to substitute into this to get my general solution. So I'm going to have exponential 1 over 2x. A cos, what is my beta? My beta is with lambda all over 2x plus what? B sine my with lambda all over 2. Then what? I'm going to have what? I'm going to have x. So in real part, we don't have anything negative. We don't have any. You can say here is negative. So everything will be what? Positive or negative. And the boundary condition that will be given at y of 0 is equal to 0. So that means s is 0. So I'm going to have y of 0. So if I put exponential 1 over 2 0 here. So if I put 0 here, I'm going to have a cos multiplied by 0. I'm going to have a cos lambda all over 2 multiplied by 0 plus b sine lambda all over 2 multiplied by 0. So 0 is equal to exponential 0. I'm going to have a cos 0 is 1. So a times 1 is a plus b sine 0 is what? 0. So from here, my 0 is equal to what? 1 over 10 to the power of 0 is 1. Exponential 0 is 1. So therefore my a is 0. My a is 0. So let me test for my second boundary condition. Y of 1 is equal to 0. So for me, I'm going to have y of 1 is equal to exponential 1 over 2x. So whenever I see x, I put 1. Then a cos a cos lambda all over 2x. My s is 1, multiply by 1, then plus b sine lambda all over 2, 1 as well. So I'm going to have y of 1 is 0. 0 is equal to what? Exponential 1 all over 2, then a cos lambda all over 2, then b sine lambda, square root of lambda, with lambda all over 2. So yes, with lambda. So what I'm going to do next is what? I have my a already at 0. Whenever I see I put 0. So I'm going to have exponential 1 over 2x. Exponential 1 over 2 into what is my a cos with lambda all over 2, which is what? I have a at 0. So 0 times cos will give me what? Times cos here will be 0 plus b sine with lambda all over 2. So it's a long process. In this case, so we have not gotten our answer. We want to find what? We want to find what b is. So I have exponential 1 all over 2, then multiply by what? B sine square root of what? Lambda all over x. Lambda all over 2, then is equal to 0. So for me to get my b here, I can divide both by exponential 1 over 2. I'll get my b as what? 0. So I don't want this one to be what? A trivial solution. So because my a is already 0, my b can never be 0. So how can I make b not to 0? So I don't want to make b is not equal to 0. So therefore I'm going to have sine lambda all over 2 is equal to what? Sine n pi, where our n is greater than or equal to 0. That is, our n is 0, 1, 2, 3. The way we did it for the first time. So if I put sine 0 here, sine when n is 0 here, I'm going to have sine 0 as 0. When n is 1, sine 180 is 0. When n is 2, sine 2 times 180, because pi is what? 180. So what is my next step is what? To find lambda in this form. So I'm going to have sine with lambda all over 2 equals sine n pi. That is, I want to get my eigenvalue. So I want to know what this lambda is. So how can I eliminate sine and n and this over 2? I can divide both sides by sine. If I divide both sides by sine, I'm going to have lambda over 2 is equal to what? N pi. If I divide by this sine is going to what? It's going to cut this sign. So I'm going to have n pi. That's what I have here. This sign is going to remove this as well. I'm going to have pi over 2. So my next step is what? To cross multiply. If I cross multiply, I'm going to have if I cross multiply, I'm going to have pi lambda. I'm going to have lambda is equal to 2n pi. So I want to know my value for this lambda. I want to know my value for this lambda. If I know this lambda is the eigenvalue I'm looking for. So for me to know my value, and I have a square root here affecting the lambda, which is the eigenvalue, how can I omit the square root? So I have to divide both sides by what? To square both sides. If I square both sides, square will cancel square root. So I'm going to have pi is equal to 2n pi all square. Because if I take square of this lambda root of lambda, the square will cancel root. And if I take the square root of 2, that is 2 square n pi. So the square is going to affect 2n pi. So my next is what? So for now, my lambda is 2 raised to the power of 2 is 4. N raised to the power of 2, n square. Then pi raised to the power of 2, pi square. So you can see from here that my eigenvalue is equal to 4n square pi square. So how am I going to get my eigenvector? My next is to find the eigenfunction. How am I going to get the eigenfunction corresponding to this Sturm-Liouville problem? I've already gotten my eigenvalue. So when I've gotten my eigenvalue already, so For me to get my eigenfunction is to go back to my general solution. The general solution where I stated that our b is not equal to 0. I said it in our previous lesson. So this is my general solution, that I stated that b is not equal to 0. I stated here b is not equal to 0. So what gives us b is not equal to 0? It means b sine root lambda over 2. So the general solution of this is this. You can say this is the general solution. The general solution is b sine root lambda over 2x. So this is my general solution, b sine root lambda over 2x. What I need to do is what? This is my lambda. So my lambda is my eigenvalue. Whenever I see what I got from my eigenvalue, I'm going to put it here. So I'm going to get my eigenfunction corresponding to this Sturm-Liouville problem. So my general solution is yn is what? B sine yn of x, b sine root lambda all over 2 then x. So and my lambda is 4n squared by square. So I have root here. So it means if I have lambda as 4n squared by square, and so the root, so if I have root like this, so it means I'm going to take the square root of the lambda, because what we have here is what? Lambda, root lambda, not lambda. Suppose it's only lambda here, so we are going to have this one here. We get our answer. But I have square root, so I have to take the square root of that given value, that is the lambda. So if I take the square root, I'm going to have this as square root of 4 is 2, because this square root is averting everything, every item in the inside it. Square root of 4 is 2, square root of n squared. I have n squared like this, so it's going to cancel. I'm going to have n. Square root of pi squared. If I take it, I'm going to have pi. So it means you can see that this lambda root give me 2n pi. That is, so whenever I see lambda root, I'm going to replace lambda root as what? 2n pi. So my yn will be b sine root lambda. Why would my root lambda is 2n pi? So I'm going to have 2n pi over 2 then x. So I'm going to have b sine 2n pi all over 2x. 2 is going to omit, is going to cancel 2. So I will left with b sine n pi of x. So therefore the eigenfunction corresponding to this Sturm-Liouville problem is equal to b sine n pi x. So that is my eigenvalue is 4n squared pi square. 4n squared, 4n raised to the power of 2 to the what? Multiply by what? Root. So therefore my eigenvalue is 4n squared pi raised to the power of 2. So my eigenfunction is what? B sine n pi x. That is b multiplied by sine x and pi multiplied by x. I hope you find it interesting. Don't forget to subscribe to my YouTube channel. Whenever I upload any new video, you'll be notified. Thanks for watching.